जी. So we have completed the reflection of sound, right, in the previous class, and we learned the concept um, of speed calculation using the concept of echo. And echo is also used to find out the depth, to find out the distance, and to find out the cracks in the in different objects. Okay. And ultrasound is is also the type of the sound, right? That is the sound that is greater than 20,000 hertz. Okay. So that is used to find the objects, okay, to detect the stones in gallbladder, and for scanning different objects in the body, right? And प्रीनेटल स्कैनिंग जो आपके मेडिकल एक पर्पस के लिए होती है, ठीक है. ऑलराइट. आफ्टर दैट we are going to apply the formula that we have learned. Vt upon 2 equals to distance. Acha, this formula is used to find out the distance when the echo is there. In the case of echo, we are going to use this formula, V is equals to 2d upon t. Now, if the question asks you to find out the distance, right? So then we can make a subject d. आप d को subject बना दोगे और t को multiply करोगे v से and divided by 2. Okay? So this is how you are going to do it. Now, I would like to keep this question here for 30 seconds, and you can read this question first and tell me that what are you going to understand, or what is your understanding. Okay.
Ship.
Yes, beta.
Second. It is. s-
The question demands you to find out the distance, right?
Hmm.
ठीक है.
It is like 640 meters.
640 meter. Uh, Wonderful. You if you are correct, that definitely, mashallah, that you have applied the correct concept. Okay, let me calculate myself as well. So sound from the siren of a ship is reflected by a cliff, right? So an echo is heard by a sailor on the deck of the ship after 4 seconds, right? So the echo time is given to you, that is 4 seconds. Okay. The speed of sound
Hmm.
that is given here is 320 meter per second. How far? So that means we have to find out a distance. Now, since we can see echo word is there, so for echo, we always use the formula. The formula for echo is V equals to twice of distance upon T. Okay. Now we have to make D subject. So it will become Vt upon 2, right? Clear? So what are we
Hmm.
going to do is we just plug the values. So 320 times 4 divided by time. Oh, sorry. Yeah, divide by 2. Hmm. Vt divided by, yes, okay, fine. So two ones are 2 and two twos are 4, 640. Wonderful, good, excellent, good job. Clear? So let me take out another question. Hmm.
Hmm.
Yes. See this one? Ji beta. Which statement about the speed of sound is correct? Sound travels fastest in a medium, sorry, in a vacuum. Sound travels fastest in gases. Sound travels fastest in liquids or fastest in solids.
Solids.
Solids. ठीक है. अच्छा, does sound travel in vacuum?
Mm,
Yes. Does sound travel in vacuum? Acha,
yes.
no, beta, sound doesn't travel in vacuum because in vacuum there are no particles and sound is produced due to the vibration of particles. Clear? So when there are no
Yes.
particles, so how can the sound, travel in vacuum? Clear? So sound cannot
Mm,
travel in vacuum, right? Acha, which frequency is in the ultrasound range? Ultrasound is the sound that is greater than the human audible range. Okay, so human audible range is maximum limit is 20,000 hertz, right? 20,000 hertz is the maximum limit of human audible, right? So
mm,
ultrasound is greater than 20,000. So which frequency in the following, right, is the ultrasound? 35, 350,
35,
3,500, or 35,000?
35,000.
35,000. Good. See this one? Ji beta. Acha, remember, recall the concept of compression. Recall the concept of compression, beta. That
Mm,
in compression, the particles are closer, right? And there's greater
yes.
pressure and greater density. You remember? So the graph
Mm,
shows how the pressure varies as a sound wave passes through air, which point represents our compression, A, B, C, or D. So you can see the labelings of the graph. Air pressure is on the y-axis and time is on the x-axis. So at what point, right, the air pressure is greater, that will be the compression. Clear?
mm.
So which point should it be?
B.
B. B. Okay. ठीक है. अच्छा जी, open up in the middle. Right. Hmm. Here's another question. During a thunderstorm, there is an interval of 1.70 second between an observer seeing the lightning and hearing the thunder, right? The speed of sound is 340 meter per second, right? What is the distance between the observer and the storm, right? Okay, so um, lightning and hearing the thunder, right? So are we going to apply a formula of echo here? Is this a case of echo? Is there a reflection of sound taking place in the given question?
No.
No. So how are we going to do this? Are we going to use a simple formula that is without echo? Since this is D is equals to VT. Yes,
Mm,
because they are asking to find out the distance. What is the distance between the observer and the storm? So how can I, elaborate it? So if this is the storm, right? And this is the observer. Okay. So the distance between them is going to be D, right? So what is the
Mhm.
time what is the time between them? Because light takes 1.5 okay, sorry. There is an interval of 1.70 second between observer seeing the lightning and the hearing the thunder, right? So the distance is not given, but the time taken by the wave to reach the observer is the time that is taken is 1.70 second, right?
Mhm.
So we are going to apply this here. The speed of sound is 340 times time is 1.70. अच्छा देखो, वो क्या रहा है कि स्टॉर्म जो लाइटनिंग हुई है ना, वो तो उसको रीच कर गई है ना, वो तो रीच कर गई, लेकिन उसके बाद जब साउंड वेव्स आई हैं, ठीक है, तो साउंड वेव्स आने में कितना टाइम लगा है? साउंड वेव्स आने में कितना टाइम लगा है बेटा उसको? 1.70 सेकेंड।
1.7
जीरो,
seconds.
हाँ, सेकेंड्स, क्लियर। सो व्हाट शुड बी द
Yes.
आंसर? व्हाट शुड बी द आंसर बेटा? जी, 340 टाइम्स 1.70, 1.70 is 578 meter, right? Clear? Now I'm trying to find out another question where we can apply echo formula, okay? So here's one question, and we are going to answer. Um, uh, Figure 6.1 shows the path of a sound wave from source X, right? So path of sound wave, right? Okay. And then it gets reflected and it will reach to the Y, right? ठीक है, ये तो हो जाएगा. State why a person standing at point Y hears an echo. Okay, देखो echo का मतलब ये होता है कि one sound after another sound, right? One sound after one sound. Clear? ठीक है. तो हो क्या रहा है कि the sound waves reach directly from X to Y. The sound waves reach directly from X to Y, right? And from X to Y before sound being reflected, before sound before the sound being reflected from the wall, right? So before wall, sound is also coming from X to Y directly. Okay. That's why one sound wave will reach to Y directly, and another sound wave will be received at Y after being reflected from the wall, and then it reaches the Y. Clear? ठीक है? Okay, let's do this question. An echo sounder on a ship produces a pulse of sound. The echo is received by the echo sounder after 2 seconds, right? So we can see the term echo in the question. So this question is related to reflection of sound. So we are definitely going to use the formula for echo, which is what? 2D upon T. Clear? Okay, this formula is always used when there's an echo, right? Now over here, depth word is used in the question. What is the depth of the sea water below the ship? Now, beta, depth measure karna hai. As I told you, this thing, the echo is also used to find out the distance, right? Okay. So again, we are going to make a formula, make D subject. हमें D को subject बनाना होगा. तो सबसे पहले हम यहाँ पे data बना लेते हैं. We can make a data. The speed of the sound that is traveling in water is 1500 meter per second. ठीक है?
Hmm.
Clear? And the depth we have to find out is question mark. And the time is 2 seconds. See, the echo time is 2 seconds. Clear? ठीक है?
Hmm.
Now we can directly use this formula Vt upon 2. ठीक है? Plug the values 1500 times the time and divide by 2. So the answer would be, what will be the answer, beta?
3,000.
15, huh? 1500 meter. Clear?
Yes.
1500 meter is the distance. सही है, ये आपका 1500 मीटर बन गया.
Hmm.
Clear?
Okay.
So I hope now the things are clear to you, how to find out the distance using the formula of echo. Clear? ठीक है? Here's another question we can do. जी. A man holding a starting pistol stands 640 meter away from a spectator, right? Okay, so spectator is here and he is 640 meter away from this, the person holding a starting pistol, right? The spectator hears the sound of the starting pistol 2 seconds after seeing the flash, right? तो अब उसने लाइट तो पहले देख ली है, so that ensures के light travels faster than the sound wave, okay? तो अब आप देखो कि लाइट को देखने के बाद जो उसको साउंड वेव मिली है वो मिली है 2 सेकंड. ठीक है, साउंड वेव्स उसको रिसीव हुई है 2 सेकंड के बाद. क्लियर? सो फ्रॉम द पिस्टल यूजिंग द इंफॉर्मेशन, व्हाट इज द स्पीड ऑफ साउंड इन द एयर? So for this question, again we have to make a data 640 meter, and the time that is taken is 2.0 second. Or what is the speed? So speed we can find out. Acha, are you observing any echo? Yes, in the question?
No.
No. So we are not going to use the formula for echo. Okay, we can apply this formula directly. Clear? So the distance is 640 divided by the time 2, and that is going to be 320 meter per second. Okay, 2 ones are 2 and 2 320s are 640. ठीक है? Any confusion? क्या हुआ? मुझे लगता है आपको डिवीजन का मसला है कोई है. हम्म. हेलो.
Yes.
डिवीजन में आपको कोई मसला रहता है क्या? या
No.
अच्छा, चलिए ठीक है. सही बेटा. सो दिस इज हाउ वी हैव डन कपल ऑफ क्वेश्चंस रिलेटेड टू एको. क्लियर? तो कुछ एक थोड़ा बहुत एमसीक्यू हो गया, और थोड़ा सा हमने एक किस तरह आर्टिकुलेट करना होता है वो क्वेश्चन देख लिया. ठीक है. सो इंशाल्लाह कंप्रेशन, रेयरफैक्शन वगैरह, लॉन्गिट्यूडनल वेव्स क्या होती हैं, ट्रांसफर्स वेव क्या होती हैं, यू शुड कीप दीज ऑल थिंग्स इन योर माइंड. ठीक है. आपके अब तक जो लेक्चर्स में अर्थ फिजिक्स का जो कंप्लीट हुआ है, सो यू कैन सी हियर वी हैव डन दीज ऑल थिंग्स: एम्पलीट्यूड, फ्रीक्वेंसी, पिच. क्लियर? और ट्रांसफर वेव्स क्या होती हैं, कंप्रेशन क्या होता है, रेयरफैक्शन क्या होता है. ठीक है. व्हाट इज द सोर्स ऑफ द वाइब्रेशन अवर हैंड. ठीक है, ये चीज़ हमने पढ़ी है. अच्छा, कंप्रेशन में क्या होता है, पार्टिकल्स आर क्लोज टू ईच अदर, हाई प्रेशर, हाई डेंसिटी. ठीक है. एंड आई टॉक अबाउट द डेंसिटी एज वेल हियर, मास पर यूनिट वॉल्यूम, कितना मास कितने वॉल्यूम में डिस्ट्रीब्यूट हुआ हुआ होता है, दैट इज कॉल्ड द डेंसिटी. ठीक है. हाउ वेव्स ट्रांसफर एनर्जी. ठीक है. Through vibrations, through disturbance. the waves are produced and they transfer energy through vibrating particles. Okay, so this is how we have covered the main basic concepts of waves, right? So
Mm.
inshallah, in the next class, we will be starting um, the next topic. Okay, that is going to be 6.3, right? Clear?
Mm. Yes.
All right, ठीक है. Plus 6.3 start.